My greetings again. Greetings. Hope everybody's doing well. Hello, everybody. So we're going to get into lesson 9. We're still doing photoelectric effect. So over here, for lesson 9, we're going to do question 10. And so over here, this is question 10 so this is a final paper. This is November 2024. Okay. This is November 2024. So let's get into it. Okay. Let's get into the question. So 10.1, they say define the term photoelectric effect. That's the first question they want, the definition. Okay. We're required to define. So what is the definition there? The process whereby electrons are ejected. Electrons are ejected from a particular metal surface when light uh, of a suitable frequency. When light of a suitable frequency is incident on the metal surface. And then 10.2, okay, let's go to 10.2. So that was all they want for 10.1 is the definition. And then, so for 10.2, they say this: red light, blue light, and green light are shown simultaneously on a sheet of potassium, okay, as shown in the diagram below. Each color of light consists of a single frequency. Two maximum kinetic energies of the ejected electrons are possible, namely 6.96 multiplied by 10 negative 20 and 2.65 multiplied by 10 negative 20. Each ejected electron has only one of these maximum kinetic energies. Now, they say which color of light is responsible for ejecting electrons that have a maximum kinetic energy of 2.65 multiplied by 10 negative 20. So what do we see here? So they say two maximum kinetic energies of the ejected photoelectrons are possible. So the 6 here is greater than the 2. Okay, so what do we know? We know from the Roy G. Beeve. So these are the colors. And what happens? The frequency is increasing. The frequency increases this way. When you go from left to right, the frequency is going high. So what we can see here is that green is bigger than yellow and is also bigger than red. So in this case, we have red and we have green and we have blue. So meaning blue has the highest frequency of all of them. Okay. So if there are two maximum kinetic energies here, it means that G will correspond with 2.65, which is green, because 2.65 is less than 6 here. So the frequency for the green light will be less than the frequency for the blue light. So the 6.96 will be for the blue light. Okay. So if I can just say this. So this will be for the blue light and the green will be for the 2.65, because we can see according to the sequence here that this is how they move. Okay. So it's going to be the green light. So the 2.65 is going to be the green light, because we don't consider the red here, because the red has less frequency than both green and blue. Okay. So in this case, our answer here is going to be green. That's going to be our answer. Explain the answer to 10.2.1. Okay. So, okay, this is where we're going to say. So, green color, green color green color has a bigger frequency than red and smaller frequency than blue. And then so we're going to say, so green color will therefore eject electrons with a lower kinetic energy than blue. Okay, so yes, that is the explanation. That's how it explains it. Now, 10.2.3 say the electrons with a maximum kinetic energy of 2.65 are ejected by light. That is the frequency of that. Okay, so they gave us the kinetic energy and the frequency. Now they say calculate the frequency of the light that ejected. So we can get the work function from this, isn't it? Then they say calculate the frequency of the light that ejected electrons with a maximum kinetic energy of 6.96. So here from this, we can get the work function because we have the frequency and we have the kinetic energy. So we're going to start there. Okay. So for 10.2.3, we start by finding the so we're going to say E equals to work function plus EK max. So then it's going to be HF equals to W plus EK max. So then it's going to be HF minus EK max equals to W. So then we can substitute the frequency. So then we use the constant here. So then we can say 6.63 multiplied by 10 negative 34. And then we substitute the frequency. And then we minus the. So the frequency is how much? 5.85, 10, 14. So 5.85, 10, 14. Then minus the kinetic energy, which is how much? The kinetic energy, which is 2.65, 10 negative 20. 2.65 multiplied by 10 negative 20 equals to W. So W naught. So then we can use a calculator here to get the work function. And then from there, we're then going to come again and we say E equals to the work function plus EK max. EK maximum, the maximum kinetic energy. Then we're then going to say, we're going to find the frequency here because the work function will come from this. The work function does not change, isn't it? The work function is the work function of the material. So it remains the same. So if we want the frequency here, we have to say HF equals to, and then the work function plus EK max, maximum. And then, so we then have to say, therefore, F will be equal to the work function plus EK max, and then we divide by the constant. So we just make this here, and then it's going to be equal to, so we have to go back and find that. So you use a calculator here. How much do we get? Press everything here into the calculator. It gives me 3.61 and then 10, negative 19. Three point 61, and then 10, negative 19. 3.61, 10, negative 19. And then, so the maximum energy now is for the other thing, is for the other light, frequency of light. So calculate the frequency of light that ejected electrons with a maximum kinetic energy of 6.96. So the kinetic energy changes here because the frequency has changed. So now it's 6.96 multiplied by 10, negative 20 equals to 6.96, and then we use a calculator there. Gives me, I get 6.5 multiplied by 10 multiplied by 10. Oh no, it's positive, it's not negative. So it's 14, and then hertz. So this is the frequency for the light that emitted this frequency, meaning for the blue light. We know it's for the blue light at this point because there is red, green, and blue. So it's for the, and you can see the frequency here is even higher than the frequency previously. The frequency was 5.98, 5.85, I meant to say. Now the frequency here is 6.5. So it is the blue light out of the three lights, or out of the red, green, and blue. So this is gonna be the blue light. Okay. But then they didn't ask us that question, so we don't need to answer. So 10.2.4. 10.2.4, what are they saying? They say the intensity of the red light is increased, while the intensities of the blue light and the green light remain the same. What effect will this change have on the rate at which electrons are ejected? Choose from increases, decreases, or remains the same. Okay, this one is tricky because now what we said is that the intensity increases the what? It increases the rate at which electrons are ejected. But then in this case, it will remain the same. Why? It remains the same. And we were not asked to explain here, but I will explain. So it's confusing because the intensity was increased, but then why are you saying the number of ejected electrons will remain the same? Because why? We have observed that in this case, the frequency of the red light, the frequency of the red light is less than the threshold frequency, meaning the energy of the what? The energy of the red light is less than the work function. So even if we increase the intensity, it doesn't have enough energy to eject electrons. So the intensity of the light in this case will have no impact because the frequency is less than the threshold frequency. So that's why we say it remains the same. Although we are increasing the intensity of light, it's because of the frequency. The frequency is lower than the threshold frequency. So do not be confused here. Okay. And then let's go to 10.3. So 10.3, they say some of the atoms of a hot gas made up of a single element are in an excited state. The spectrum formed by the hot gas is observed on a screen in a darkened room. The spectrum consists of specific colored lines on a black background. Name the type of spectrum formed. Okay. Emission spectrum. And they say explain the presence of the color lines in the spectrum. Okay. So this is the line emission spectrum. Okay. So the color lines, okay, the color lines represents frequencies. Frequencies of emitted photons. When atoms move from a higher state to a lower state. So that is the explanation in this case. So, okay. So now this is what happens. Okay, yeah, that's the explanation here. The different frequencies will produce different colors on the screen, right? On the dark screen. So as we have observed that in this question, some colors can be red, some colors can be blue, some colors can be green. Okay, so the colors here, the color of the light will depend on the frequency of that light. Okay, the light that is being emitted from the atom. Okay, so yes, that's it for the question 10, and that's it for, I think that's enough for lesson 9. So thank you again for watching. Thank you for tuning in, and let us hope to see you on the next lesson. Leave your questions in the comments and let me know what you don't understand. Bye bye for now, and I hope to see you in lesson 10.